There are a lot of people who love to cook, which include my mom. One day, my mom asked me to cook some coriander leaves in the garden. But guess what? Instead of coriander leaves, I took some celery leaves. This is what it looks like. Coriander and celery looks alike. And that's why I make this research called Coriander or Celery. Hi, my name is Adlan Slambudi and I'm from Indonesia. The problem statement in my research are both species, coriander and celery, are difficult to differentiate, and there isn't any machine learning system has been created to identify both species. There are some applications that we can use to identify plants. However, the applications are paid applications. The first application that I tried is this, and it's quite accurate. And the second application is not that accurate. And the last application, I couldn't try it because there isn't any free trial. The method that I use for this research are SVD PCA and deep learning. By using SVD, we can extract some features. In these pictures, I extracted from more than 40,000 features to only 1,600 features. And we still know that it's a picture of a leaf, which means it still has most of the information. PCA. I used 20 leaf images with white background for each class. By using PCA, I look for the means of all leaves and then normalize it. Normalize is each data minus by the means of all leaves. This graph shows PCA in 3 dimensions, and as you can see, the data points are still mixed together, which means we cannot differentiate both species in 3 dimensions. And that's why I tried to look in more than 3 dimensions, and the accuracy increased until 95%, in 27 until 40 dimensions. However, there are a lot of limitations by using PCA, and that's why I use another method. The method is deep learning. This image shows how it works. First of all, convolution, where we can take the most important and dominant features only. For example, this is an edge detection, and then followed by ReLU, pooling, and so on, and then divided into 2 classes, coriander and celery. Due to lack of data, I used transfer learning to improve the accuracy. Transfer learning is a research problem in machine learning that focuses on storing knowledge gained while solving one problem and applying it to different but related problems. For this research, I used the VGG16 model. And now I will show you how my app works. We can use it in any devices with a web access. And this time, on my phone. This is how it looks like. First of all, we have to take a picture. And here I have 2 leaves, and for example, I will try this one. Take a photo of it, use the photo, and then upload it. And as you can see, it says that it's a celery leaf with an accuracy of 87%, which is correct. It is in the right class and quite accurate. So that's how it works. In this research, there are some limitations, which include only 4 coriander leaves and celery leaves, and only 3 leaves in the frame. The conclusions are, by using PCA, we can differentiate both species, but we have to make sure that there isn't any big difference. For example, background, because for the data that I use is only white background. And we can differentiate celery and coriander by using neural network with 90% accuracy. This is the program that I made and used for my app by using Jupyter Notebook. So I used 90 images of each class, 90 celery leaf and 90 coriander leaves, but only 10 tasks with an equal of 100. First of all, I resized my image to make it all the same. with the size of 3 times 150 times 150, and also rescale it. And in this program I use augmentation, which is flip, horizontal flip. And this is the model that I made. As I said, I use activation function called ReLU, max pooling and convolutional. And then flatten, dense. The last is divided into two classes, which are Coriander and Celery. And then I save the model so it can be used for the app. And I also look for the loss and accuracy. The accuracy for this program, this model, is quite high, it's 90%. So that is the program. This program is created to make a new model by using transfer learning to make the accuracy increase. It is also made in a Jupyter notebook. I use a VGG16 for my model. So first of all, I load it. And this is the model. And I have to shape into 150 times 150 times 3 to make it the same as the last program. And I have to cut some of the layers. And then I add some new layers that I want to use, which include flatten and dense with an activation function ReLU and also sigma. And here it is. In this model, I also use the same data. I insert the same data as the last program and train it. The train accuracy is quite nice, 99%. And the test is also 99%, which increased from the last program is 90%, so it's more accurate and better. However, I haven't used it in my app, and it will be my future work. So yeah, that's it. The last program that I made is autoencoder to compare it with PCA. However, it doesn't work because there is something wrong, so it doesn't work. As I said, the accuracy is quite low and the result is not good. We cannot tell that it's a image of a leaf. So as I said, there is something wrong, and it will be in my future work to make it work properly and so that I can compare it with PCA. For my future work, I will use data augmentation to gain more data, compare PCA and autoencoder, and also find the best model, then apply it by using transfer learning. Now we know that celery and coriander can be differentiated by using deep learning.